work session. Hello, everyone. All right. All right. I don't even know how to like see the chat. Here you go, chat. Here you go. All right. I'm gonna try implementing a velocity buffer in Nuake. I'm gonna do a very crude implementation, well, at least try to. And yeah, I roughly know what I have to do. Just a matter of actually doing it. I'm gonna try and do it on my own with like as few resources as possible. All right. So ideally, I would add like a new viewport texture here we can view, and would be the velocity buffer. But before we can do that, we need to create a new texture target in the G buffer. So right now we have albedo, normal, I think depth. Oh, I thought it was gonna be broken, but we would add velocity. So let's start with that. So I'm gonna first start with clean slate. I don't want like a million tabs and start with that and be confusing. So going to scene render this. So velocity is gonna be, let's do like normal RGB for now. Can change it later. So attachment number 3 is gonna be velocity. Yeah. So also need to edit our shaders. One thing that's annoying is I don't have a way of live reloading shaders. I don't know why. I used to have it, but ever since I started embedding my shaders, it stopped working and I never fixed it. So let's see. How do I do that? There we go. So here we have our shaders. And we have the G buffer shader over here. There we go. So we're gonna need to pass the old matrix and the new one, which is gonna be annoying. anyway. Here's our outputs. Ooh, I don't remember why I was doing that. 5. Gee, emissive. Oh, I'm using 4. I'm just not using 3. I'm not using 5. 3. Oh yeah, I am. 3 and 4 used. It's 5. Yeah, let me put them in order. All right. So 5 is going to be our velocity. There you go. And we're going to take in here. Let's say previous position. I don't know. Previous view model. Let's do that. And I'm gonna be outputting also a previous fragment position. Like that. And for now, we're just gonna do like this. And we're also gonna get on the other side. Previous frag position. Okay. So we should be having that. Oops. And let's output in the, this is not good anymore. It's gonna be G velocity. Let's do that for now. So we should be having the red velocity on my G buffer. Let's build assets. Also in the editor interface, we have draw viewport. And we also have our, no, it's draw overlay or something. Yeah. And then we should be having graphics bar that, let's add velocity. Selected viewports equal I. All right, where's this used? 4. We're gonna do that. Pick texture. And I think it was 4, right? No, it's 5. So we should be having a view of our velocity buffer in the editor. That's going to be the first thing we need to visualize the result. Then next thing on the list is storing the previous position on the CPU. So let's see. So we have velocity should be red. There you go. That's easy. Now we just need to write that. So ideally what I would do is avoid doing like multiplication like for the previous position as well. So I'm gonna try and store the pre-computed, pre-multiplied camera position. The projection view and model multiplied together. So I think that I can do that on the transform component. It's gonna be like previous transform. It's gonna be public. I don't need that. And I think the right place to do it, which would make sense, is in the render right before drawing it. It would also write to the last frame right after rendering them. So under scene, we have the gbuffer pass. Here would be a nice. Oh, but I'm batching everything. So it'd be the flush. What do I have in the flush? I have the render list, which is just models. Well, so I have the entity ID. I think I would do it separately. I would add like another pass right after the gbuffer pass. Let's see. So it did here. Like save previous. Save previous matrix. Alright. Let's not make a function, it's just raw dog it. Okay, that's all I need. That's all I need for now. Just normal model. Do I need to? Yeah, I do need the visibility. All right, so here, transform dot previous transforms is I have. I think that's it. Yeah, I always forget. Yeah, like that. So I'm setting the previous position to the current one for the next frame. So I'm preparing work. And now in my gbuffer pass, I need to also pass in these. So transform. So yeah, I would do it here. Gbuffer shader. What did I call it? Previous view model. There you go. So for every model that's visible has a model resource, I'm setting a previous transform. At first, the first frame it's gonna be like the first frame is gonna have like a big shift because I'm not initializing that on the first frame. I'm not handling that case, but that's fine for now. I'm fine having like a super nauseating motion blur on the first frame. Also, I want to put something more chill music wise. Let's do like let's do that. There you go. All right. So I should be doing something in that shader, which would be getting the frag position. So it's gonna be this multiplied by previous view model, right? Right? It's gonna be world space position. I don't know if I can just calculate the velocity like that, but Let's try. What's the scale? All right, let's do a little bit of research on how they calculate it. But also I kind of want to just try for the sake of it. So we have normal material. Do I not have position? What am I doing with frag pause? Offset. Oh, I was trying to do some like weird stuff. Okay. Difference? No. Position difference. It's gonna be frag pause minus. What's this? Previous frag pause. It's gonna be interesting. It's gonna be huge though in one frame. Actually, I don't know. Let's just try it. Sorry. Let's see. No, it doesn't make sense to keep it in 3D because if it's going away from the camera, I don't think we're putting blur on that. We can't blur in 3D, so I need to transform it in screen space or like NDC. Oh, I'm not compiling. Let's see. It's gonna be funky. If it works, I hope it works. Also, I'm not used to speaking out loud while I'm programming and thinking. I don't know if I sound crazy, like stuttering and... I don't know. Oh yeah. I can't call this view. Dummy. Alright, shader failed to compile. I'm doing a vec. This is vec 4. That's why. All right. Why can't... All right. Whatever. Let's see. Ooh. This is kind of cool. All right, so it's not moving like that. Super interesting. Okay. So it's moving with the camera, but not the model. Maybe it's not moving fast enough. That's kind of cool. I'm not sure what is that supposed to be. So there's always velocity to these. That's super interesting. So maybe these. It shouldn't be yellow, but it's definitely working for that one. So let's do a little test scene. So there's something wrong with these rigid bodies. But the whole like world is fine. All right. I think I was on the right path with oh, maybe it doesn't have a visibility component and it's not getting filtered. No, it definitely does. All right, let's transform these into screen space. Also, let's see if it's the right thing to do. Let's do some research. Okay, my browser stopped working. Boom. Okay. So, velocity per... do some research. Is that an article? World space position. Oh, I can't pre-multiply. I have to use the inverse view projection. All right. Not too sure now. So all of this is not used anymore. Oops. I deleted too much. Okay. Why am I setting inverse projection to just projection? Am I even using that? No, I'm not. That's funny. Okay. Okay, I don't think I can use that. Oh, wait. Wait. Hold on. Okay, so I have this camera. Now let's say this was the previous one. My cube was here, now it's here. Now that we have the position in world space. Wait, that's not even world space. What am I saying? Okay. Can I just ditch this? Do I even need that? Do I even need like the Z? Okay, another thing I should do is make a scene with like moving stuff. So let's do that. Let's put this cube here. Let's create a new script. There we go. Let's make it move it up and down. Object mover. I'm gonna do this. Global position. We're also gonna do a whole delta time thingy. We're gonna accumulate. Then we're gonna do initial height plus. Do I have sim? We're gonna do delta time, and we want one is fine. That's okay. Let's do it like kind of slow for now. And the amplitude is gonna be, it's gonna be 1 for now. All right. Hello. Okay, the chat is working. All right, let's make this cube move. It should be moving. It's moving very slow. Too slow. And this is too big. All right. Let's go into the velocity view. I don't know why it's not working for these models, but working for this. Am I doing anything different here? No, I'm simply getting the previous transform. So it's green. I have a position difference. It shouldn't be green. So is this just not getting set correctly? Let's just print the names of whatever entity is being set. So, okay. All right. So it's working for some entities, not all of them. So brush and rigid body. But not model. Oh yeah, model, rigid body. It is, okay. That's super weird. What is going on? Oh. Oh, I know why. Damn. Okay, so the problem is that I'm pushing all my mesh that I need to render into a queue with their transform. And then when I do flush, I render all of them with the same shader. The problem is I'm sending the previous transform here. So it's only on the last iteration of this that it's getting the previous model correctly. So I need to add this to the queue, and I'm adding this to render list, and I'm making these render mesh, which should have the previous transform. So I'm gonna add this to the queue thing. I'm gonna add it here. And optionally also the previous transform. There you go. It's by default gonna be 0. transform here. And previous transform. All right. So we have to give this a default value. We'll handle that case later. So here in the gbuffer pass, we are going to include previous transform. We're going to nuke that here. And then in the flush, we're also gonna set that here. And cat is in the way. It's gonna be previous transform. Location. What's new with this? Use view model. All right, this might crash, but it should fix the problem we have with the cubes. It crashed. I think it's the assert because it's not finding it in what shader is it not finding it? Shadow pass. Yeah, let's call it that for now. Telling you speed implementation. Yep. Why is it doing that? Seems like a simple position buffer. Interesting. Let's see. Flush. Oh, I'm stupid. This is not an unsigned int. It will never be previous transform. Let's put a breakpoint here. Old school RuneScape OST going hard. Hell yeah. Alright, that should be better. This is 0. This is 0. This is 0. That's why it's always 0. I'm not using it. I can't use move on a construct. Okay. Okay. Oh, damn it. I'm stupid. Wait, no, I am. Am I stupid? No, I'm not. Maybe I am. Let's see. Okay, this has data. Alright. I am stupid. Should work now. Forgot one. Okay. Okay, this seems to be working. It's not going fast enough. Let's make it faster. Speed. It's gonna be 3. Also, I wonder if I can. Not sure if this works. Can I do like default value? 1. Okay, I have speed here. Okay, let's make it like 5. Where is it? It's not going fast enough. That's because I'm not using speed in my code. Okay. All right. I'm gonna move this on the on update. Seems to be pretty jittery. Could you explain? Hello. Could you explain roughly how the velocity buffer works? Or just storing the last position of the object? So I'm trying to figure it out myself. But essentially what I'm doing is I'm storing the previous frame transform while I'm rendering the current frame. So then I have in screen space the previous position of that same pixel. And then I'm calculating the difference and then storing that into the like RGB of a texture in my G buffer. So like I'm moving my camera and it's like red is like the right and then green is vertical. So if I'm moving vertically it's green and horizontally it's red. So we have that. Though I'm not sure if that's enough. If that's what I need to like keep going. I'm not sure. How delayed? So this will work for skin model suit. Yeah, but I would need to handle that differently because then I would need to store all the bones transform of the previous frame for one model. So it's multiple transform for one model. So I would need to like make a separate shader just for skinned models. But I don't even know. Like I'm trying to. Let's see. I want to see an example of like a velocity buffer on YouTube. Like how it actually looks. Why is it on Facebook? All right. I want to see the velocity. So I guess that could be an example. So it's moving like that. Okay, hold on. What is he doing? Maybe on shader toy. Let's see. Velocity buffer. That's 2D. This is kind of cool. Wait, can I use that for like debugging? Okay. Let's see. PAA implementation. Is he talking about the velocity buffer? Velocity, that's how it should look like. What if I rotate the cube as well? Wait. Am I doing... This is gonna rotate for me? Trying to make it spin. Oh yeah, I do be spinning. Perfect. Does that look like this guy's thing? I don't even know if it's right. I want to see a velocity buffer. Maybe velocity textures. Yeah, I think. Let's move it down. And let's put our player. Where's my player? Oh, I'm spawning it through script. I think. Yeah. Let's make a stupid spawn point. Let's move our player here. And I just want to add like a little box collider for like a gizmo. So our player's gonna spawn here. Spawn point. Let's do that. Okay. That works. Let's move it more down. Under player. Fuck. Let's change this to initial position. Here we go. Should be fine. Not spinning fast enough anymore. It's my little cube. 5. Yeah. Kind of. Remember a website that was kind of good with like a bunch of. Is it that one? Can't remember. No. I think it was no. Yeah, it was that website. It was that website. Is there a velocity one? Motion blur. You need to know where things were last framed. Figure out where things are now. Simple the current vertex position. Figure out where things were last framed. Transform the current position from view space to world space in the previous frame of view world, and then transform back to view space from world space. What the hell? I just want to see what it looks like. Looks like it's working. Yeah. I don't know if it's in the coordinate system we need. So, okay. One thing I know for sure is we need to transform it back. Instead of being -1 to 1 space to be 0 to 1. So that's the first thing we need to do. So position difference +1 divided by 2. Can I even do that? All right. Oh boy. What's going on? Surely it failed to compile my shader. Oh shit. What the hell? What the hell, man? All right. Okay. So if I'm rotating this guy, really should be 0. Oh no, it's 0.5. Okay, I'm stupid. I'm dumb. So it is. Okay, it's working like that, but like it's also working like that. Okay. Okay, I think it's working. I think it is. I don't know if it's in the right hello. I don't know if it's in the right like coordinate system or whatever. Let's see. PAA implementation. Let's find some good old literature. Let's see the pipeline. Here's a pipeline for TA for a static scene. Is there another one for non-static scene? Dynamic scene. The pipeline for dynamic scene is largely the same as the one for static scene except for a few minor changes. In order to use TA on the dynamic scene, we need to generate another data called per pixel velocity buffer. This data allows us to calculate the position of the pixels in the previous frame. Cool, we need the depth, velocity, also the shaded color of this frame. And then we resolve color. Update history. I don't know what that means. Update history. Velocity texture. Although it's called velocity, the value stored in the texture is not actually velocity. Each textile and velocity texture stores delta between the current frame position and the previous frame position for each pixel, okay? Okay. Alright, let's take a look at how we can calculate velocity in the shader. Oh, we see. Okay, we got it. Okay, that's what I did. Unjittered position of the vertex of the current frame. So the final vertex shader looks like this. Calculate velocity. Hold pause divided by W. And then it's... Okay, I'm not doing the division by W. And then he's also inverting the direction. Okay. And the resolve. There's also very limited sum of settings, except that we now use the velocity texture to calculate sampling coordinates for the history texture. It's also very simple. Okay, so I guess we need to do the static scene one first. Okay. Stop the music for a second. Let's do it. So, first step is to render a scene with jittering. The way the scene is rendered in this step is almost identical to the way the scene is rendered normally. The only difference is that the scene is slightly shifted in various directions and distances. In other words, jittered. For this, vertex shader is slightly modified. In the vertex shader, after clip space position is calculated, a jitter offset is added to the clip space position. So model position, then view projection, okay. And then we add viewport params jitter times clip position.w. Hey, good night. So I'm not sure if the jittered version is like, I'm just replacing my normal output with just a jittered version that we won't notice. Now we have the current frame color texture by rendering scene with jittering. We use this texture in another texture called history texture. To produce anti-aliased image for the current frame, history texture is simply the output of the resolve step from a previous frame. In this step, we render a full screen quad. We read the current color and the last frame. Then we just mix those two colors to generate a new color. Very simple. All right. Okay, that's fine. Wait. So when you're doing TAA, it's always shaking a little bit, but we don't notice it. No way. That's crazy. Also, how do they generate the jittering? Viewport params jitter. Each frame uses a different jitter offset in its parent frame, and it's within a frame, the entire scene is rendered using the same jitter offset. For the jitter offset values, there are multiple possible options. What I'm going to use in this is what's called Halton sequence. Below is the 16 jitter offsets generated. Okay, so it's like not even a pixel. It's like half, like a third of a pixel. That's why we don't see it. Okay. Oh, how's the dog doing? Oh, I didn't see that one. I'm sorry. I'm good. Trying to work on something new, doing temporal stuff, taking a break from the whole prefab thing. So essentially, I'm gonna be able to do motion blur with this. So the light flashing and everything is the speed of the things on screen. So like that's why if I'm moving this um like this, if I'm moving it like this, it's moving like on the red because that's X, and then green on the Y. So with this, I'll be able to get TAA, which a lot of people don't like, but I do. And then per object motion blur as well. So it's all per object. So if I'm selecting a cube and I'm moving it, oops, sorry, I'm moving a cube here. Move it kind of close. Probably can see it faintly. I'm not moving it fast enough, but you get the point. Yeah, you can kind of see it. Anyway, so we're gonna render. Here's what we're gonna do. We're gonna do it in the scene renderer. We're gonna store. Let's write it. Oh shit. Musty buffer. All right. This is done. 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 Cool. TAA now. So first thing first is gonna be store jitter data. Then we're gonna push the data, and then we're gonna render scene with jitter. Okay. And then we need to store. How are we gonna do this? We need to keep the previous frame. So it's gonna be store last frame in texture. And then once that's done, history texture, then mix the two colors together, update the history, and render the frame. And then we should have static TAA. All right. And then static TAA. Let's start with that. Okay. Okay. So first, let's go scene renderer H. And then we got this private stuff here. It's going to be a vector of vector 2, like this. And it's going to be jitter offsets, call it like that for now. And then here we're gonna generate that data. So let's see. This is what we need. Jitter offsets. Like that. All right. There we go. We got jitter offsets. That's good. But then when the view size change, we need to update that. So that's going to be that can be like a static one. And then one we actually have per scene render, that's going to be the scaled one. It's going to be scaled jitter offsets like that. We're also going to make a new method that's going to update that. It's going to be void update jitter offsets. Boom. It's going to be with the new viewport size. We're going to pass that as primary, so viewport size. Clear. It's going to be jitter point and jitter offsets. I'm going to do this. He's doing this. Offset X. All right. It's gonna be jitter point X minus 0.5 divided by viewport size. Oops. Dot X multiplied by 2. All right. Like this. And we're gonna do it here. So if frame buffer dot size is not equal to gbuffer we're gonna update our jitter points every time the viewport gets updated. So that's the first step here. So for example, if we pass in, we're gonna validate our data over here with the example of the website. All right. Once that is done, I think I'm gonna stop here because the goal of the stream was to get velocity buffer implemented. And we've gone a little bit overboard, but oh yeah, I forgot to make this static. To scene render jitter offsets. I think I'm gonna do this with the lambda like this. Where did I put the data? Nowhere. What? Really? Oh, there you go. This, boom. Boom. There you go. I'm doing it with a lambda because I learned this today, by the way. You can statically initialize a container with a lambda that returns your content, and then you call it immediately. So you can define a lambda and call it immediately doing that. I learned that today. But yeah, okay. Let's do update jitter offsets with resolution. All right. So this is a static thing, and we can initialize like that with a function call. So we can actually like step inside and debug it. Where's it crashing? Here. What's the index? Oh. I'm gonna do it at the top. Here we go. All right. Still out of range. No. 0. I need to push back. Has a capacity of 16. Damn. Log, he's setting limits. I know, right? Usually I'm PD working until like 2 a.m. Okay. Breakpoint. Come on. Is it not resizing? No. Ah. Because because I'm resizing right. Where am I doing resize? Doing it right here. Let's try that. So we should be having the exact same sequence as this. So that's what I'm trying to do. So he's doing it with a 1600 by 1200. 1600 by 1200. Okay. So okay. So we can go debug Windows locals. And we'll see here in this and scaled jitter offsets. This is not the same at all. Uh-oh. What about the non-scaled one? What am I doing differently? So it's doing offset x minus 0.5 divided by viewport size dot x times 2. Get the final jitter offsets as below. Let's debug it. Okay. First point 0, 0, 0. Fine. So the first should be 0 minus 0.5. What the hell? Whoops, not camera. So 0 minus 0.5 minus 0.5 divided by what's view size? It's the resolution, sorry. Divided by 1600 times 2. Why is it 0 for him? That's not right. His math is wrong. 0 minus 0.5. Okay. Let's reverse engineer his thing. I don't think he scaled them. Wait. Oh no, my data is wrong. I knew I wasn't that smart. Oh, I pasted the. All right, my fault. That's my fault. Thank God I'm debugging it step by step. Younger me would have just be like, yeah, that's fine. It's the same as him. Now actually stop and debug. Make sure everything's right. Okay. Now let's see. This scaled. Now we should have it be the same. So minus 0.0003. Good. And then the last one's minus 0.000586. Perfect. That's good. That's very good. So he's adding in the clip position times clip plus that W. Okay, let's add it to our G buffer. Yeah. Previous fragments. Out to position. Clip position. Float for clip position. Boom. Clip position plus equal jitter times clip position W times clip position. Good. And it's going to be uniform float vec2 u jitter. U jitter. And then in the G buffer pass, I'm going to do G buffer jitter set uniform u jitter. And also gotta add like an increment for our frame. It's gonna be uint. It's gonna be jitter index 0. Scale jitter offsets. Jitter index. We're gonna increment it, and we're gonna do jitter. Okay. Let's try that. So hopefully it should be moving very slightly. And I think to debug it, I'm also gonna exaggerate it in the shader and see, or just right there. Just trying to scale it like to actually see it move. Okay, the shader failed to compile. That's awesome. When I write float 4, did I write float 4 somewhere? God damn it. This is what happens when you work with DirectX during the day and then you come home to OpenGL. Just mix them. Okay. Um, that's weird. Please compare. Why? Okay. You jitter. Back to. Oh, it's not finding something called U jitter. Interesting. It's right there. It's right there. All right. So I'm going to try one last time. I'm going to push and I'm going to end the stream. I was setting myself a limit of 9 p.m. and now it's 9:15. Oh shit. Permission denied. Yeah. Okay. Well, tomorrow I'm going to try and finish this. Thank you. Hell yeah. Thank you. Have a good night.